proceeding for the day, I now take the honor to present offer today's guest for the first session of the day, Dr. Santosh Bhagwat Rane, President of the Institution's Innovation Council and former Dean Academics at Sardar Patel College of Engineering, Mumbai. Now I request Development Program to kindly offer a bouquet and kit to welcome our guest speaker. Thank you so much, sir. Now I would like to call Dr. P.S. Chauhan, sir, coordinator of
Privilege to extend my warm welcome to Professor Santosh Rane. He is not only the eminent speaker here, he is one of my fast friends. We are associated for the faculty development, for the development of the academic research, for the development of the new things. I can say that for the last 6 and 7 years, we are working together. And as far as personal characteristics of Santosh Rane ji is concerned, really, he is, we can say that a very sound researcher also, quality conscious. He has a certification that is a black belt. I am totally unaware with this fact. What is it actually? Because my field is industrial engineering, but mainly focus on the defects and reduction, rejection. I was working on it also. And for the last 15 years, I am in administration, pure administration. But really, I heard a lot. At the same time, he is working, he has trained. Approximately thing will be here. If there is any query in between the session, you may ask a question from the Raniji. Thank you once again, Raniji, to be in the campus and to travel from Mumbai to Gwalior and then again Gwalior to Mumbai. It is also one of the hectic tasks for anyone who is very difficult to spare the 1 minute and 2 minutes. Thank you once again.
Thank you so much, sir. Now it is an honor and privilege to introduce our distinguished guest speaker for the morning session, Dr. Santosh Bhagwat Rane, sir, President of the Institution Innovation Counseling and former Dean Academics at Sardar Patel College of Engineering, Mumbai. Dr. Rane is a visionary leader in the field of smart system integration, cyber physical systems, and digital optimization. With over 25 years of academic and industry experience, he stands as one of India's most respected voices in quality improvement, business excellence, and Industry 4.0 technologies. He holds an MTech and PhD from VJIT Mumbai and is a certified Master Black Belt in Lean Six Sigma from the Indian Statistical Institute. His remarkable achievements include 26 patents with 12 granted, 120 plus research publications, and guidance to 13 PhD scholars. He has trained thousands of professionals, led 450 plus business excellence projects, and has been honored with prestigious awards including the Visionary Innovation Leadership Award 2025, SAE India Foundation Champion Award, and multiple national accolades from CIE and IIE. Currently, he also holds key leadership roles in SAE India, IIE Mumbai chapter, and serves on the editorial boards of global journals and Emerald publication. With such a distinguished background as an unwavering commitment to knowledge dissemination, we are truly privileged to have him with us today. Sir, we are truly honored to have with us. I now invite you to take the session forward. Sir, please.
Please, thank you. चलो Fine. Good morning to everyone. First of all, I give my sincere thanks to one of my fast friends, our Honorable Vice Chancellor Sir, Premanandji Chauhan, for inviting me over here to get associated with you all. I'm also thankful to Professor Nishant for giving all necessary support in coming over here as a part of the logistics and many more things. Dear friends, I'm also thankful to you all for being the participant for this prestigious Atal program offered by AICT, and I congratulate the entire team for securing such a nice program from AICT. So the topic which is given to me as cyber physical systems and the digital twin in real-time optimization, as this is the third day of the program, about those things. So I will particularly skip these things, and whatever the things are necessary, if at all, those we will be discussing in due course of time during the discussions, if at all there is a requirement. We will start with the digital twin, and digital twin is one of the topmost technology being considered by the Gartner in 2017 survey. So what is the digital twin? What is the basic difference between the simulation model and the digital twin? So these kind of concepts particularly we will be discussing. My today's entire presentation with reference to this particular part will be covering these things. What is digital twin? What are the different types of the digital twin? What are the different applications of the digital twin in the business, in automotive value chain, in supply chain, and manufacturing, healthcare? What different kind of technologies are needed for establishing the digital twin for the system as such? What kind of softwares are necessary? What are the enablers and the challenges in establishing the digital twins of the systems? What is the current market scenario? Then I will be switching over to the typical case study of the fan manufacturing company, where I will be emphasizing more on the Industry 5.0 enabled fan manufacturing company, and then one more case study of the Arbor Press, digital twinning of the Arbor Press for reduction in the material utilization, particularly optimization of the Arbor Press design by using the digital twin. So these two case studies will be discussed in detail. So I will start with this. So dear friends, what is the digital twin? We already learned what is IoTification. So in IoTification, what is happening basically, we have the physical systems. Maybe we have the typical machine available in our workshop. Now we wanted to get this data and simulate this data. So IoT played an important role. Because of the IoT, we can capture the real-time data by using the sensors. The sensors are fitted at the different locations in XYZ orientation as per the typical technical requirements to capture almost all the different parameters of the system as such. These sensors are capturing the data in a real time. These sensors are then sending this data to the cloud through IoT gateway and edge computing. At edge computing, particularly, the data is analyzed to know if there are some major issues getting developed. So without any delay, the action can be taken. So for that purpose, the edge computing, this particular technology work. Now that data is sent to the cloud where the data is analyzed. This data is in the form of a big data with the high velocity, high variety and high volume. Now the entire organization as such or it may be the entire supply chain, supplier, original equipment manufacturer, then distributor, warehouse manager, third party logistic service provider, customer, reverse logistic manager, and so on. It may be the entire supply chain. So we can have the digital twinning of these. Okay. So particularly in establishing the digital twin, we want the two-way communication. In IoTification, we have only one-way communication, and the business inferences are derived at the cloud computing. Now in digital twinning, we also initiate the actions. These actions based on these business inferences, and based on these actions, the assets are controlled to give the best possible results. That is the basic difference between the IoTification and the digital twinning. So all these best tomorrow, and in 2025 onwards, you will find that many such kind of systems are getting converted into the digital twins. However, the path is not easy. It's really challenging because collecting the data, particularly for the digital twin, there is a different kind of a method. Here we need the 3D modeling. So we have lot of scope for mechanical engineers. We have a lot of scope for the civil engineers, okay, who can develop the 3D models of the assets. Asset may be anything. It may be the machine, it may be the building, it may be the bridge, it may be anything. Any typical seminar hall, conference hall, anything, okay. So we need the people to develop the 3D model of the assets. And for developing these 3D models, this is the good news for the traditional people, that yes, we have the role to perform, because we are doing the same thing, and it particularly mechanical engineers and the civil engineers are the masters in 3D modeling, because their whole life is the same thing. Okay, so by using the answers, yes, we can develop the 3D models. So here sensor technology play an important role to capture all the parameters, and then the 3D models, whatever are developed by using the answers, such kind of powerful softwares, these models will be particularly the second layer, where the system is getting represented in a digital form. Then we have the simulation model particularly. So we simulate the system for the what if kind of analysis. We try to develop the different scenarios. What will happen if I introduce one more worker? What will happen if I particularly switch over from supplier A to supplier B? What will happen if I replace the metal by the plastic? Okay, so such kind of what if kind of scenarios are developed, and we try to simulate the model. So that is the another layer. Then in the next layer particularly, based on this, we receive a very good kind of a virtual layer. Virtual layer means here we are using augmented reality, virtual reality, such kind of softwares. Okay, so augmented reality that adds the digital information in the existing physical system, whereas virtual reality that will create the whole virtual system to give and display the information. In this manner, this augmented reality, virtual reality, sometimes mixed reality, these typical technologies are useful for creating the virtual layer of the digital twin. And this will facilitate us to see how the things can be controlled. And then the last layer is particularly the service layer or business layer. Different authors, different organizations give the different titles to that. Basically, it is the application layer, where the whatever the business inferences are derived, based on those business inferences, the decisions are taken. And these decisions are then sent, particularly as the action commands for monitoring the performance of our systems. When we are talking about the manufacturing systems, yes. So it is like that. Fine. So this is all. I have given the entire story in the few minutes. Now I will expand these things step by step. Okay. Whatever are there, I have given in the 4-5 minutes only for the entire session as an abstract. Okay. Now I will expand this entire discussion step by step. So here in digital twin, what we have the physical asset, we have the digital replica. We need the two-way communication. Okay. In IoTification, we have only one-way communication. But that second part, two-way, that is a communication from the cloud for actually monitoring the performance, controlling the performance, that is absent, and hence the digital twinning is necessary. Now here the concept of the digital twin is originated from NASA for their aerospace applications. Then Mr. Greaves and his team worked in this domain and took this particular concept as a reality for all the people, all the industries. So as I have already told you, we need the 3D models, and for this purpose we need the traditional engineers, mechanical and civil engineers. Particularly for establishing the perfect digital twin, to get the total success of digital twinning, we need to develop the 3D model of every single component of the machine. So you can imagine how much time is necessary, how much efforts are necessary, and how much is the cost involved in that. So all these are the real-time challenges. Everything is not a cakewalk. These are the real-time challenges because we need to establish the 3D model, and we do not have the 3D model of everything. Okay. Then we need to integrate those things. Okay. So particularly establishing, getting the 3D model, but then developing the digital twin is a long journey. Okay. So digital thread means particularly the smallest component we have converted into, particularly we have developed the digital twin of the smallest component, that is called as a digital twin. Here I have taken one small example. Here there is a hospital. You will see that at the left hand side there is a hospital. It is an asset with all the necessary infrastructure, reception, then particularly the doctor's place, consulting room, and many more things. At the right hand side there is a virtual replica of this entire hospital with all the necessary centers. Okay. Particularly there is a two-way communication between the virtual hospital and the actual hospital. That's what is basically the digital twinning, to optimize the processes. Okay. Next. So what are the different types? Particularly we can have the digital twin of a component. We can have the digital twin of the machine. We can have the digital twin of the entire manufacturing plant or manufacturing line. We can have the digital twin of the entire process as such. So these are the different types of the digital twin. To have your attention better, I tried to include the MCQ because that was also one of the requirement given. So here, what is digital twin? It is a virtual replica of physical asset, process, and a system. Okay, fine. So definition, it is a virtual representation of an object or a system designed to reflect a physical object accurately. It spans the object's life cycle as such. Okay, and here we are dealing with the real-time data. We are capturing the real-time data and we are taking the decisions in real time to get the best optimized results. So digital twin technology is one among the top 10 strategic technologies trends named by Gartner in 2017. This concept represents the convergence of the physical and the virtual world. Okay, here it has the three components. You can see the digital definition of the counterpart, then it is the operational data, and another the information model. Okay, now if you go through the various definitions given by the various authors, we will say that here digital twin is a comprehensive physical and functional description of a component, product or a system which includes more or less all information which could be useful in all the current and subsequent life cycle phases. So it is a multi-physical, multi-scale, probabilistic simulation model of a complex system. Okay, the effortless integration of the data between a physical and virtual machine in either. So different authors, they try to define the digital twin as per their thought processes. Okay, so digital twins are the computational representations of both living and non-living objects and the processes. So to establish the perfect replica of the entire system as such, we have to have the digital twinning of every single entity in the system. So when I talk about, let us say, a manufacturing plant as such, we have the cobots, we have the human being, we need to have the digital twinning of cobots as well as human being, and then how these are interacting with each other and how they basically augment each other to create the best production deliverables. That's what we need to identify. Next, which of the following is not a component of digital twin system as such? So please, I need an answer from you. Yeah. Yes, you are right. Thank you. So dear friends, digital twin, this concept is actually